Imagine waking up tomorrow, grabbing that first cup of coffee, and looking out your window. But instead of seeing green grass, gray asphalt, or, normal dirt, literally everything you see is a sleek, dark surface reflecting the morning sun. Well, let's dive right into this wild thought experiment today. Welcome to this explainer where we're going to imagine a world completely blanketed in solar panels. I mean, every single inch of our planet's surface dedicated to harvesting the power of the sun. It sounds like the ultimate sci-fi utopia, right? A total planetary scale transformation in the relentless pursuit of unlimited clean energy.
Naturally, the intuitive first step in this massive mega project would be the most arid, sun-drenched places on Earth. Picture vast, endless deserts, places like the Sahara, the Mojave, or the Gobi, just completely transformed. Instead of rolling sand dunes and cracked earth, you've got infinite, shimmering oceans of glass and silicon just baking in that intense heat. Because deserts receive an incredible amount of direct sunlight with virtually zero cloud cover, they seem like, well, the absolute perfect prime real estate for massive solar farms stretching across entire continents.
But if we're going to truly cover the Earth, we have to bring it closer to home. Imagine the sheer visual shock of our urban and suburban landscapes entirely reimagined. Every single highway, every winding neighborhood street, every sprawling parking lot, and literally every rooftop in your city completely glazed over with dark panels. The aesthetic contrast would be absolutely striking, replacing all the diverse textures of nature and human architecture with this uniform, engineered grid. Buildings wouldn't just consume power anymore. They'd act as continuous generators, just humming with captured solar energy from dawn until dusk. Okay, let's push this thought experiment all the way to its absolute absurd extreme. Because remember, almost 70% of the Earth's surface is water. So to truly cover the Earth, we'd have to conquer the deep blue sea. Imagine standing on a shoreline and seeing nothing, and I mean nothing, but an endless expanse of floating solar arrays riding the swells, covering the Pacific, the Atlantic, and the Indian Oceans as far as the eye can see. And this dramatic setup leads us to a massive, critical question. If we actually manage to pull off this monumental, logic-defying engineering feat, would we instantly unlock an era of unlimited, basically free electricity? Would we finally conquer our global energy crisis once and for all? Or would this utopian fantasy of unlimited clean energy actually backfire on us, creating entirely new, catastrophic problems that we literally never saw coming? Now, the foundational tech behind all this is beautifully simple. A solar panel sits in direct sunlight, the photovoltaic materials inside absorb those photons, and they convert that solar radiation directly into an electric current that feeds the grid to power your EV or your fridge. It's an elegant, silent process that works flawlessly on your roof. But taking this brilliantly simple little local equation and trying to force it onto a planetary scale, yeah, that is exactly where the math entirely breaks down. Because taking this technology and trying to plaster it over rugged mountain ranges, deep canyons, and dense forests creates enormous, unrealistic logistical nightmares. Covering the Earth is a fascinating thought experiment for sure, but as a physical construction project, it is completely impossible. Think about the sheer material science required to anchor heavy glass panels to the side of a jagged, snowy peak like Everest, or the paradox of installing a global canopy over the Amazon rainforest while somehow trying to keep the forest alive underneath. The scale simply transcends human capability. And that brings us to the harsh economic realities. You might think all this abundant solar energy means completely free electricity for everyone on Earth. But the crucial point here is that generating the power is only a tiny fraction of the actual cost. Energy is practically useless if it's stranded. Moving gigawatts of electricity from a sprawling array out in the middle of the Gobi Desert all the way to an apartment building in New York City requires overcoming massive transmission losses and distribution hurdles that totally defy our current infrastructure. To actually make this planetary solar grid work, humanity would have to pay astronomical prices to build unthinkably expensive high-voltage transmission lines crossing oceans and continents. We would need grid infrastructure capable of handling massive, unpredictable surges in power. And then, oh man, there is the ongoing nightmare of maintenance. Panels get coated in dust, they shatter in heavy hailstorms, and the silicon just naturally degrades over time. Just imagine the logistics. Who exactly is grabbing a squeegee and heading out to the middle of the Sahara or the open Pacific Ocean to clean bird droppings and grime of trillions of solar panels? And since we're talking about covering the entire globe, we really need to dwell on those oceans for a moment. Moving this infrastructure out into the open water takes a terrestrial maintenance headache and turns it into the ultimate boss-level engineering challenge. While floating solar actually does exist today on a very small scale, like on protected calm reservoirs,
Covering the open oceans is a whole different beast entirely. The ocean is a violently moving machine. You're fighting massive rogue waves and Category 5 hurricanes that would smash panels to pieces in seconds. You have relentless saltwater corrosion actively eating away at the wiring and metal frames 24/7. Plus, the physical blockade of a floating global grid would instantly freeze commercial shipping lanes and fishing routes, literally bringing the entire global economy to a grinding halt. But beyond the logistics and the economics, this brings us to an incredibly ironic twist in our explainer, the environmental complication. We rightfully think of solar panels as the ultimate green technology, designed to save the planet from carbon emissions. But in our extreme thought experiment, scaling them infinitely actually turns them into the planet's biggest threat. By literally blanketing the Earth's surface in dark panels, we would inadvertently break the Earth's original multi-billion-year-old solar power system. Photosynthesis. Plants absolutely need direct sunlight to survive. Without it, they die. And if the flora dies, the fauna that rely on it lose their food and their habitats, triggering a massive collapse of the food chain. Even worse for us, the vital, fertile farmland we rely on to grow our own crops would be completely wiped out.
So we really have to ask ourselves this incredibly difficult question. Could our relentless, single-minded pursuit of clean energy accidentally destroy the very ecosystems we are trying to save? The reality is that Earth needs its surface area for much, much more than just human energy production. The land is a living, breathing system. It sequesters carbon, it supports biodiversity, and it grows our food. It is not just some barren battery terminal waiting for our cities to plug into it.
Furthermore, we have to consider the thermodynamics of the planet, specifically something called the albedo effect. This is the Earth's natural ability to reflect sunlight back into space via light-colored surfaces like snow, ice, and bright sand. Dark solar panels, however, are expressly designed to absorb sunlight, converting some to electricity, sure, but also generating a significant amount of residual heat. By replacing naturally reflective ground with dark, heat-absorbing panels on a planetary scale, we could trap immense amounts of thermal energy, triggering severe, totally unpredictable local climate shifts.
But then we hit the absolute ultimate hurdle of this entire thought experiment. It's a massive, glaring, astronomical truth that planners and engineers have to face every single day. The Earth rotates. The sun simply does not shine everywhere all the time. When you tally up the energy gaps, the reality of solar dependency is pretty stark. At any given moment, half the planet is pitched in total darkness, experiencing nighttime. Add to that the heavy cloud cover from massive storm fronts, monsoon seasons, and the dramatic reality of short winter days in the northern and southern hemispheres. Under these conditions, our planetary solar grid wouldn't provide a steady, reliable stream of power. Instead, global generation would constantly flatline, creating a violently fluctuating pulse of energy. And because of these enormous gaps in power generation, a solar-covered Earth would instantly collapse without a historically unprecedented energy storage system. We would need global battery facilities on a scale that frankly defies current material science, like mining more lithium and rare earth metals than practically exist in the crust, just to store the daytime surplus for the nighttime demand. The logistical tightrope of trying to instantly shoot daytime power from the sunny hemisphere over to the dark hemisphere is, at least currently, completely impossible. Section 1. A realistic solar future. Let's pull back from the extreme thought experiment and look at the grounded reality of clean energy.
The wonderful news is that we don't actually need to pave the world in glass to power our civilization. The actual real-world solution relies on smart co-location and intense efficiency. We can utilize spaces that are already developed, putting canopies over sprawling parking lots, utilizing city rooftops, and targeting specific barren industrial areas. We must actively avoid conflicts with pristine nature and vital agricultural land. And equally important, we've got to prioritize building modern energy storage and decentralized smart grids so we can actually deploy the solar power we generate when the sun goes down.
The main takeaway from this explainer is that finding the right places for solar energy is far more important than sheer overwhelming scale. Precision always beats brute force. Throwing down more panels isn't inherently better if they're installed in the wrong places, disrupting ecosystems, or just stranding power. True sustainability is really about working harmoniously with our planet rather than just paving over it. So, we've explored the wild extremes and the grounded realities. Now that you know the hidden risks, the logistical hurdles, and the incredible rewards of solar power, I want to hear your ideas. If you could cover just one specific place on Earth with solar panels to maximize efficiency and absolutely minimize environmental harm, where exactly would you put them? Drop your answer to this question in the comments below. I can't wait to read your thoughts.
Keep learning, keep questioning, and I'll catch you next time.